Okay, today we're going to practice differentiating logs with this function of x. G of x is ln of x times e to the negative 2x. So we're going to use two rules here that are worth noting. The first one is that log base a of m times n is log base a of m plus log base a of n. That is a very important rule. We're going to apply it, which is going to make our life easier. Oh, there's an airplane going by. Okay. So then our second rule that we're going to apply here is going to just be the product rule. But then after the product rule, we're going to use the power log rule. So I'm going to write it down here. I'm going to just write it down here real quick so I don't need to do it later. And that, wow, I'm only giving myself so much space. I hope I can live up to the challenge. Okay, and that is that log a of m to the k is the same thing as k times log base a of m. It's the same exact thing. So we're going to be able to pull this exponent down once we have rewritten our function. So keep that in mind. Our first step is actually going to be, this is just going to be we're differentiating g of x with respect to x. So this is just our derivative on the left-hand side. It's going to be, first we have this first rule. So it's going to be ln of x plus ln of e to the negative 2x, and then all of that prime, because we haven't actually started taking the derivative yet. We're just rewriting still. Okay, and now we're going to start actually taking, I think we're going to do one more piece of rewriting already. We're not going to leave that till later. We're going to do that now. This is actually going to be ln x plus negative 2x times ln e. Okay, prime. All of this is prime. Now we're going to take the derivative. So the first thing we're going to do is we're going to remember that the derivative of ln x is always 1 over x. There's no chain rule hidden there, so that's just going to become 1 over x. And then we're going to have dy dx of negative 2x times ln e. Well, you might think that this is going to require the product rule, but actually ln e is also just a constant. In fact, ln e is always 1. ln e is 1. And that makes sense in case you've forgotten this, because it's been a while, because ln is just log base e. And so if you had log base e of e equals y, it would mean that e to the y would equal e to the 1, and so therefore y would equal 1. Okay, so let's put that in. Let's put that in brackets to make it look a bit nicer. Okay, so now we're going to remember that ln e is 1, but we're deriving, right? So we can't just do whatever we want. We're going to pull it out, but it's just 1, so it doesn't matter. I mean, the derivative of 1 is 0, but in this particular case, it's just 1, so whatever we multiplied by is just itself anyway. This becomes 1 over x times ln e times dy dx of negative 2x. Okay, well, that is not too hard to solve. X is x to the 1, so we're just going to end up with negative 2. So that's going to be 1 over x times 1 times negative 2. Okay, well that is just going to become 1 over x times negative 2. And that's just going to become negative 2 over x. That doesn't look right. That doesn't look right. See, in math we make mistakes so we can learn. So let's figure out what went wrong, because this is not the solution actually. The solution is, Oh, I know what went wrong. I know what went wrong. We lost a plus over here. We lost a plus over here, and then we turned it into a multiplication over there. This is really not multiplied by negative 2. So okay, so our issue was not too far back. We haven't done a ton wrong. This is a plus. This is a plus, and this is a plus. And so this is actually 1 over x minus 2, and that is our final solution. Troubleshooting teaches you to be better at math, so just make sure you always look at whether or not a solution looks correct or not.